When designing a display module, image quality is important. But in many applications, durability is equally critical. Displays used in industrial equipment, automotive systems, medical devices, and outdoor products often face vibration, shock, and unexpected impact. So, how do engineers design a display with better impact resistance? A reliable display is not only about choosing a strong glass. It requires a complete mechanical and structural design. Number, understanding display failure under impact. When a display receives external impact, the force travels through multiple layers. The cover glass, touch panel, optical adhesive, LCD module, and internal components all experience mechanical stress. If the stress exceeds the material strength, failures can occur. Common failures include cracked cover glass, LCD damage, touch function failure, and layer separation. Factor 1. Cover material selection. The first step is selecting the right cover material. Glass is widely used because of its excellent hardness, optical performance, and scratch resistance. For applications requiring higher impact resistance, engineers may consider materials such as strengthened glass, PMMA, or PC. The material selection depends on the balance between hardness, impact resistance, weight, and optical requirements. Factor 2. Glass thickness and structure design. Glass thickness has a direct impact on mechanical strength. A thicker glass layer can provide better impact resistance. However, increasing thickness also adds weight and affects product design. Engineers must optimize glass thickness, display size, and installation requirements. Edge design is also critical. Rounded edges and proper chamfer processing can reduce stress concentration and lower the risk of cracking. Factor 3. Optical bonding improvement. Optical bonding not only improves display visibility, it also improves mechanical strength. By filling the air gap between layers with optical adhesive, the display becomes a more solid structure. This reduces movement between layers and improves resistance against vibration and shock. Factor 4. Frame and housing design. A strong display requires proper mechanical support. The front frame and housing structure help distribute external forces. Good mechanical design can prevent stress from directly transferring to sensitive components. For industrial and automotive applications, metal frames and reinforced structures are commonly used. Factor 5. Reliability testing. A professional display solution must go through reliability testing. Common tests include drop testing, impact testing, vibration testing, thermal cycling, and environmental testing. These tests verify whether the display can maintain stable performance under real-world conditions. Applications requiring high impact resistance. Impact-resistant displays are widely used in automotive displays, industrial control systems, medical equipment, outdoor terminals, military and transportation applications. In these environments, display failure can affect safety, efficiency, and user experience. A durable display is not created by a single component. It is the result of careful material selection, structural design, bonding technology, and reliability testing. By designing every layer properly, engineers can create displays that deliver both excellent performance and long-term reliability. This is how we build stronger display solutions. A reliable display is not only designed for today, it is designed for years of operation.